Hey, you know how some people just can't leave well enough alone? Got to say that applies to us when it comes to these engine projects.
Yeah, especially when it comes to making horsepower. And this time, it's back to our friend, the Ford 460. Remember?
Delivery, horsepower.
Our low budget build all started with a Junkyard motor we disassembled for some basic machining on the block, heads, and crankshaft. Then we loaded it with stock replacement pistons, hanging on refurbished stock rods. We replaced the springs for taller, stiffer ones from Comp, and installed one of their hydraulic flat tappet cams. Now after a basic timing chain setup, we dropped in the rest of our valve train components and buttoned up the top end with a new aluminum intake. Then to save a few bucks, we upgraded the stock distributor. We bolted up a part store replacement oil pump and pickup, and to keep our budget in the $2,000 range, we even did a refurb job on some of the other parts. The old big block liked a lot of timing on the dyno and eventually pumped out 493 foot-pounds of torque and 378 horsepower.
So, mission accomplished on the budget build, but guess what? We're tearing it down now to take this thing to the next power level. The stock cast iron crank and rods and replacement pistons are going to be stout enough to handle the upgrades we got in store, but we can definitely help it out with this. It's a trick flow stud girdle that really is going to beef up those 2-bolt main caps. Comes with ARP bolts. And as you can see right here, it's got provision for an oil pump and pickup. And wait till you see what we got in store for that. Since Mike put moly lube on the threads, torque specs are 88 foot-pounds. On top, the valve covers come off, as well as the dual plane intake we installed during our budget build. That's because we're replacing it with this, a trick flow track heat single plane intake designed for big block Fords operating in the 3,500 to 8,000 RPM range. This thing makes more power and torque thanks to this one-piece spider design with extended runners for better flow. Plus, it has a raised plenum, and that's good for better velocity and fuel atomization. Oh, and check this out. Boss is here, so we can add nitrous later on.
For more power and better valve train geometry, we're getting rid of the stamped steel rocker arms for a set of these new trick flows that have a 1.73 rocker ratio. They also have needle-bearing fulcrums and a relief cut in the front for more valve spring clearance. We'll use them on heads that are a vast improvement over these stock cast iron boat anchors. In fact, our head swap is going to make the biggest power difference. TrickFlow's aluminum power ports are a perfect match for our new intake. Now these things have 290cc intake runners and 74cc combustion chambers, and that's compared to 91s in the factory head, so we are going to have a higher compression ratio. For the exhaust ports, check this out. These things are a night and day difference over the factories. Take a look over here. On these, the air has to flow up and around and then down to escape. Now the TrickFlow ports are raised from the stock location to allow a lot better airflow.
We're using new Felpro gaskets for our heads, and orientation's a no-brainer, says front right there. To keep our heads in place, we're replacing the head bolts with ARP studs. It's very important to only install them finger tight. That way the studs only stretch on their vertical axis. We are reusing the entire front end assembly on this 460, but we got to remove everything now to make way for a cam swap. This hydraulic flat tappet camshaft was a good choice for a budget-minded performance setup, but not for our new power plant. In fact, in its place is going this Comp hydraulic roller that was spec'd out for us by engine builder John Conzi. Now, the gross valve lift of this flat tappet is 494 compared to 685 here, and you can see the different shapes of the lobes and why this one's going to hold the valves open longer. Duration at 50 thousandths lift is 256 on the intake, 264 on the exhaust side. Now here's a special Kazi touch. He double pins the cam for added strength during heavy loads. And it's all held in place with this brass retaining plate. Kazi also drills out an extra hole in the timing gear so it mates up with the camshaft. Now it's time to reassemble the front just the way it came off. But unless you mark your boats, you get to play that game. Hey, where do the big ones and little ones go?
To finish up the bottom end, we're going to make a major improvement to our 460's oiling system. Now on stock OEM pumps, the mounting foot has a tendency to crack or even break completely off under high RPMs. So Kazi sent us one of his CNC machine pumps that has a bulletproof mounting pad. Now this thing will promote better oiling at higher RPM and even down at idle. With the supplied gasket, studs, and shaft, it's that easy.
We'll finish the bottom end with this upgraded 7-quart capacity Moroso pan with trapdoor baffling, hear it, and a scraper to help the crank spin freely. Now, next time we're going to show you how to measure for the push rods, finish the build, and bring this thing up from 389 to well over 500 horsepower. Of course, we couldn't dyno it today anyway. We got a motor in there getting ready for a unique horsepower TV test. No matter what brand you use, spark plugs all do the same job. They force an electrical arc, create combustion, and well, that's it. But could one plug make more horsepower, improve emissions, and fuel economy? We answered the first question last year when we tested several premium plugs in our shop. In fact, we matched up E3 spark plugs with a leading competitor in our dyno using a 383 small block for a power plant. After 3 runs with each set, we got more horsepower with E3s, 5.5, but at the same time saw less brake-specific fuel consumption. This time, E3s betting the farm that their Diamond Fire plugs produce less harmful emissions than the other brands. So we brought in these guys from Sensors Inc. for some high-tech help.
We stick this on the side of the vehicles that we're testing so we can get relative humidity and temperature. Your NOx numbers will change according to how much RH is being pulled into the intake.
This is an exhaust flow meter, and what this enables us to do is actually measure the amount of exhaust flow.
The test engine we're using this time is our fuel-injected LS mule motor. Emissions and fuel economy go hand in hand, so if E3s produce cleaner exhaust than the competitor, that could be a major milestone.
We have a lot of confidence in what our product can do and the combustion efficiencies that it produces. And with the new SimTech system that is now available, we feel like it's one more effort to go improve the technology and to show the results and that better combustion.
This could have far-reaching benefits when other emissions-minded manufacturers want to back up their product's claims.
The OEM have been using it, the EPA has been using it for their own tests on the road. And I think it behooves the manufacturers of specialty parts to be looking into this technology as ways of evaluating their products for emissions and fuel economy, because as you say, they do go hand in hand.
We'll get data from the competitors' plugs first. Since this test is all about real-world driving conditions, we'll run the engine at 2,000 RPM for 2 minutes, then 2,500 for another 2 minutes, and finally 3,000 for 2 minutes. Not as exciting as power pools, but again, our mission is all about emissions. Now we install the E3s to duplicate the first run. Water temperature, oil pressure, everything's got to be exactly the same.
We're looking at the CO2 from the first set of plugs, and you can see that we're a little over 7% on the CO2, which is basically an equation of fuel economy. And when we look over at the E3 plugs, we're at 6.8 pretty consistently across all the runs, about 2 or 3%. The CO is what we're going to look at next. Very similar readings. There's not much change from the one CO to the next. Now we're going to go to one of the main pollutants, NOx, and we can actually see a pretty significant change.
That is.
750 on the standard plugs, where the E3s are running 650 ppm.
I'd say overall the E3s came out pretty well.
Oh yeah, yeah, very good.
More horsepower, fuel economy.
That's a winner.
That's a winner.
Ever since people started tinkering with their cars, hot rodding has been a fixture on the American landscape. Whether it's burning rubber on the strip, moonshiners outrunning the law, or just cruising the street in style, hot rodding has a very colorful history. But it wouldn't be quite the same without the presence of one guy, Charlie Card. You probably know him best as Honest Charlie.
He was the real deal. Honest loved automotive. He loved racing. He loved going to Indy. He loved people that were interested in these kind of things. He liked horsepower. He liked speed. He had cars of his own.
Honest Charlie opened his speed shop in 1948 in Chattanooga, Tennessee, and it quickly grew into a coast-to-coast distributor of hot rod parts. Mike Goodman, a longtime friend and employee of Charlie's, now runs the day-to-day operations.
This traditional hot rod thing really plays to my pulse and the heart of what we're about at Honest Charlie. It was through his early catalogs and his relaxed manner of doing business that I got my early automotive education.
Those catalogs really made the speed shop stand out. Charlie was all about the customers, so he gave them something they couldn't get anywhere else: pictures of the parts they were ordering. His daughter Ann would hand draw the engines, mufflers, headers, and so forth. They also featured whimsical photos of Honest himself, as Charlie put it, and were written in Southern English. It was that combination of humor and love for the hobby that endeared Honest Charlie to hot rodders everywhere. The catalog was free, so kids would snatch them up by the thousands, bringing a whole new generation of car lovers into the fold. Charlie always loved cars and started out racing his Model T back in the 20s. Over the years, he got behind the wheel of many a roadster and flathead-powered Ford. He set records flying up Lookout Mountain in Tennessee and on the beach in Daytona. Honest got his nickname before he ever got into the speed business. He owned a restaurant where on busy days he would stick the cash register out in the street to make more room for customers. A hand-lettered sign on the register read, "How honest are you?" Pretty soon the customers were calling him Honest. He decided to open a speed shop after a customer asked if he could pay for his bill with a manifold. The business took off thanks in part to the local moonshiners who needed fast cars to transport their white lightning. Well, today Honest Charlie is the oldest mail-order speed shop in the country, and it's still headquartered in Chattanooga, just a few blocks away from the original store. From the beginning, Honest Charlie prided itself in the vast inventory of hot rod parts, and that still remains true. 32 Ford Highboys are their specialty, and no one knows them better than they do.
You can build an entire hot rod out of here. We've got chassis, we've got suspension, we've literally got every component that it takes to assemble a vehicle and get out on the road and enjoy yourself safely, do the miles, do the smiles.
Anyone who's ever built a hot rod can tell you it can be very frustrating tracking down all the parts you need. So having them all under one roof is a big plus.
Our inventory now is skewed real hard toward Model A's, 32 Fords, 33 34s, all aspects of traditional rodding. We keep a wide variety of I-beam front suspensions, Posey springs, quick change rear ends, a lot of Moon, Isky, a lot Offenhauser, a lot of these icon distributors.
So whether guys are just tinkering with an old ride or building a 32 Ford from the ground up, Mike will tell you there's still one name you can always trust.
Honest Charlie, the company, is like Honest Charlie himself, and we live and strive to live up to that heritage today.
Ed Horsepower will be right back, honestly.
Build on a budget. Horsepower projects that save you time and money.
We're always looking for cool stuff that'll save time and money in the shop. And recently I found something while searching Summit Racing's website that I had to try. Now if it works, it's gonna save time and money, and hey, it's even gonna avoid some fuel spills. It's an adjust-to-jet metering block kit from Percy's High Performance that allows you to adjust the jets on your Harley carb without removing the fuel bowls. And we're gonna try it on a 4150. First, you remove the float bowl from the carb. The adjusted jet goes in between the metering block and the fuel bowl, and because it spaces the fuel bowl out farther, the accelerator arm isn't going to reach. Well, they've got that covered from the kit. I'm going to use a roll pin punch to drive the pin out from the bottom. Now, move your pin on top and lock in the new arm. Now, as strange as this may sound, remove your jets for good. Now we can drop on the supplied gasket onto the metering block. Next up is the foam insert that goes in between the metering block and the adjust-a-jet. Now some of you may be wondering what that's for. Well, it's going to prevent fuel slosh in between the two. Now the easiest way to put together the rest of the assembly is to start 2 bolts in the top of the fuel bowl and sandwich everything else together, making sure the actuator arm is in the right position. Next, we can place the metering needle into the adjuster jet and carefully turn it until it's in the fully closed position. Make sure not to over tighten it or you'll damage the tip of the needle and throw off your adjustments. Slip on the O-ring and drop on the jam nut. Now after repeating all that on the other bowl, you're ready to play. Now to get to the initial setting, the kit also comes with an equivalency chart that's set up in 1/8 inch increments. So as you turn the metering needle out, that raises the jet size. In our case, we're going to 70 square, so we're gonna go 2 1/8. The chart didn't account for engine mods like our heads and big intake. This thing's starving for fuel, so we'll open the metering needle up 2 jet sizes. All right, the air fuel ratios look pretty good to about 4,300 RPM. Now the motor's using most of the air wide open throttle and it leans out from that point on. So we're gonna make another adjustment on the metering needle and dial this thing in a little better. We're almost dialed in, but I'm gonna make one more small adjustment on the front bowl, 1 jet size, and see where that gets us. We should be right in the ballpark. That's much better. What a cool way to tune. Take a look at this. The lines on this graph represent the air-fuel ratios. Now the first one was way too lean. The second one, we were able to get it a little richer. The third one, we were getting really close. And on the fourth, hey, that put us right in the ballpark. Now that would have been 4 jets and 4 jet changes, but all we had to do was a simple twist of the screwdriver. Now in case you were wondering, this setup also comes for Dominators, whether you're running gasoline or alcohol. Now that's all the time we have for today. Do us a favor, go tune yourself.